Hi, Geometry. So this chapter so far has been about parallel and perpendicular lines, so it makes sense that we want to look at the algebra also behind parallel and perpendicular lines. So we're going to start off here with a little theorem about parallel lines, slopes of parallel lines. What do you think would be true of those parallel lines? Well, hopefully you say that parallel lines should have the same slope. Have the same slope. And by that, we also mean that the two lines are distinct. They're not the same line. Two lines are distinct. And they're not vertical, because vertical lines don't have slope, right? Or they have an undefined slope. Now, let's do a little reminder. What is slope? Remember? So if you had 2 points, if you had an x1, y1, and an x2, y2, remember we find slope by rise over run. So you take the difference of the y values over the difference in the x values. That's our rise over run. So that is how we find slope. All right. Now we have a theorem about perpendicular lines. What do you think would be true about the slopes of perpendicular lines, or what do you remember? Well, it turns out that the product of two perpendicular lines, so when you multiply their slopes together, it will equal -1. So the product of the slopes of perpendicular, the little upside down T lines, equals -1. And the reason for that is because perpendicular lines, their slope, are negative reciprocals of each other. Negative reciprocals. That's a lot of verbiage. Okay. So what does that mean? Well, as an example, if M1 were, say, a -2, that would mean M2. So reciprocal means you always, so this is like -2 over 1. So this would be a positive 1 over 2. And then to verify, you could just go -2, times 1/2 does in fact equal a -1. So that's a quick way to verify that you have perpendicular lines. All right, so we're going to look at some of the algebra behind this. So let's do some problems here. So our first example here says that we have a line and it passes through 3,5, the point 3,5, and through this point 12K, and it is perpendicular to a line that passes through 0, 7, and 210. And we want to find the value of K that makes that a true statement. So what we're going to do with these 2 points is we're going to find each of their slopes to begin with. All right, so let's take these 2 points and find their slope. So we subtract the y values. I like to have my K in front. So I'm going to go K minus 5. I'm subtracting the 2 y values. And then on bottom, since I started with K, I have to start with 12 minus 3. And I can now simplify that, K minus 5 over 9. All right, now let's find the slope that goes through these other 2. So this second slope, I will call it M2, is going to be 10 minus 7, so I'm subtracting the y values. Since I started with the 10, I have to start with the 2 for the x, 2 minus 0, and that's going to give me 3/2. Now the issue here, though, is we want it to be perpendicular to each other. So the perpendicular slope to M2, the perpendicular slope is going to equal a -2/3. So now what I'm going to do is set up an equation. I know that I want K minus 5 over 9 to equal a negative 2/3 because we want the slope of the one to be perpendicular to the other. So I can cross multiply, or I'm just gonna, let me see, I'll do this. Step by step, I'll multiply both sides by 9 so that it cancels out here. That will give me k minus 5 equals negative 18/3, which is a negative 6. And then I'm going to add 5 to both sides. So we get that k equals a negative 1. So again, we're trying to find two slopes that are perpendicular to each other. And so we found the slope of one that had a variable, the slope of the other. We had to take the negative reciprocal because we want the perpendicular of it, set them equal to each other, solve for that variable. All right. In example 2, we are now going to determine if the lines are perpendicular, parallel, or neither. Graph the lines to verify your algebraic work. So what we're going to do is maybe even graph these first just to kind of see what's happening. All right, so I have line 1 passes through 1, 0, which would be right here, and it passes through 7, 4, my things are in the way, 6, 7, 1, so this is 7 right at the edge, 1, 2, 3, 4, there's 7, 4. I'm going to attempt to draw a straight line through them. Hopefully it's good enough. All right. So that was the line that went through, that was line 1. Let's do line 2 now. That one goes through 7, 0, which will be right here, and 3, 6, so 3, 1, 2, 3, 4, 5, 6. And I will again attempt my magic trick of drawing a straight line through 2 points without any fancy help. Ooh, not bad. All right, so we're not positive that those are perpendicular, but it definitely seems like it could be. So basically what we want to do is go through and find their slope. So the slope of line 1 is going to be 4 minus, I say 4 and I write 7. Okay, that's good. 4 minus 0, so those are the y values. Subtract the y values, then subtract my x values. 7 minus 1, and again, whichever coordinate you start with on the y, you have to start with that coordinate on the x, so this is going to be 4, 6, which reduces to 2/3. All right, now let's go to line 2. So the slope of line 2 is going to be 6 minus 0 over 3 minus 7. So that's 6 over a negative 4, which is a negative 3/2. And we can see because they are negative reciprocals, you do know that they are perpendicular, but it's kind of fun just to, like, if you ever had to actually verify it, this is the nicest way to verify it. When you take their product, you do in fact get a -1. Okay? Now we are going to write the equations of lines. So we might want to do a little review here. Write the equation of line passing through this point that is parallel to this other given line, and then graph the equations of the lines to check that they are parallel. All right, so here's the point 2, 3, 2, 1, 2, 3. We want to write the equation of a line that passes through that. So what we're going to first do is we are going to put this into what we called y equals mx plus b, which is your slope-intercept form. Sorry, my cat is being very noisy right now. So m is your slope, b is your y-intercept. That's why we call it slope-intercept. So if I put it in that form, in other words, if you isolate y, that is going to then tell us what our slope is. So we know I'm going to come down here and I'm going to subtract 2x from both sides so that I have y equals a -2x plus 2. All right, so I now want to steal the slope of that line. My slope I'm going to work with is -2, and it's going to pass through the point 2, 3. Now you have an option here. Most of you know y equals mx plus b very well. Did you know there's also this other form, y minus y1 equals m, x minus x1. That one is called your point slope form. It's a little bit easier to work with actually, because if you have a point and you have a slope, voila, you have the equation of a line. So what I can do, I'm going to do both ways for you, but I'm going to start with, we have the point, so this is our x1, this is our y1. So I'm going to write it in point slope form first. So that's going to be y minus 3, the y value, equals my slope of -2, because this one we want to be parallel, so we want the same slope, x minus the x value. Now that would be point slope form, which is totally legit, but if you don't like that, then what you can do is you can distribute this -2, and then I'm going to add 3 at the end. So we have y equals a -2x. -2 times -2 is a +4, plus 3 from the other side. These are both exactly the same equation, all right, just in 2 different forms. So they wanted us to graph these. So I have a slope of -2. So going through the point that they gave me, a slope of -2 means I'm going to go down 2 and run 1. Down 2, run 1. Because my slope was a -2, which means I'm also going up 2 and back 1. And that was interesting. I have never done that before. They got some new things going on with this. Okay, so I'm going to then try and graph that straight as I can. Now they wanted us to graph both lines. The other one was -2x plus 2, which means you're crossing here the y-intercept of 2, down 2 over 1, and they are going to both be parallel. There we go. Okay? Now, our last example, which I'm calling your turn, because if we were in class, I would make you do it on your own. You're going to go through the same process. The only twist here is that it's going to be perpendicular. So they're going to give us a point, -2, 2, -2, 2. There's that point. And we want it to be perpendicular to the given line. So what I recommend is maybe turn off the video for a second, try this on your own, and then see how you did. So knowing, I'm going to just continue. So the slope of this given line is 2, which means the perpendicular slope, which is what we want, is going to be a -1/2, the negative reciprocal. So I have my point, -2, 2. I'm going to start with point slope form. So y minus 2 equals a -1/2, x minus a -2. And if you don't like that, which is fine, I will put it in y equals mx plus b, so we have to distribute the 1/2. So we get -1/2 x minus 1 when we distribute, then plus 2. So -1 plus 2 gives me +1. Right? Yeah, -1/2, and then we're going to add 2. All right, my old answer key was wrong. So let's take a look at this. We want to graph both these lines. So let's graph my pink line first. That has a y-intercept of 1, and it's going to pass. So notice I went down 1 over 2. That is definitely, which means up 1, back 2. That's my slope of a -1/2. And then over here, let's graph the equation they gave us, y equals 2x plus 3. That has a slope of 2. So it's up 2 over 1, down 2, back 1. And I would say they look very perpendicular to me. All right. Well, I hope this was a nice little walk down algebra review lane for you.